So let's try our recap of the last lecture. So for molecular equations, we basically just trade cations and anions. So we just swap them over. So the silver is positive and the iodide is negative. On the other side, you get silver iodide. And then you got the magnesium that's positive and the nitrates that's negative. So on the other side, you got magnesium nitrate. From the charges, we write the formulas. And so since nitrate's -1, we need 2 of them to cancel the charge on a 2 positive magnesium. We use the solubility rules, so silver iodide. Iodides are generally soluble, but silver is an exception. So we write an S there for insoluble or precipitate. And then nitrates are all soluble with no exceptions, so that's why we write AQ down below. And if we go to the full ionic equation next, then we just break apart all the soluble ionic compounds. So that silver nitrate was soluble, so we break it apart. We write the charges, we write AQ next to each thing. The same with magnesium iodide. So both the magnesium and the iodide we break down. But on the other side, that silver iodide did not dissolve in water. So we absolutely did not break it down. We just left it put together. But the magnesium nitrate did, so we broke it down into magnesium. And because we had 2 nitrates, we write a coefficient. So that is the full ionic equation. And now the crowning glory. So the net-ionic equation, we remove everything that is unchanged, and so those nitrate ions on the left and the right, they haven't changed at all, so we get rid of them. The magnesium ions, they didn't change either. They were on both sides, so we're left with the things that changed. So the silver ions and the iodide ions fall in love and come together and form silver iodide. And so the net-ionic equation, we just cancel out everything that doesn't change, and boom, Bob's your uncle. That's a net-ionic equation.